Pinpoint asteroids in orbit, then hurl y'all thousands of miles an hour towards it.
The Prince Waikiki, or specifically, Diamond Head Tower. 33 floors of luxurious 4-star oceanside hotel living. Yes, I know, everyone's probably tired of me spamming my same photos in Discord all the time. But at the expense of triggering flat earthers, I just can't resist. This time I've enlisted the help of good old Tommy Gronvold, who created a 3D model for me. In this model, which actually consists of 3 different models, we have a flat model, a curved 6,371 kilometer radius model, and a 7,500 kilometer refracted radius model. Now if we look at the flat model, everything is visible all the way to the base of the building. What's also visible is a small strip of land, trees, and boats that are in front of the building. Now when we move to the curved model, which matches the 6,371 kilometer radius of the Earth, it's pretty obvious that this model matches exactly what I see in reality. We can't see any of the trees, the island, or the boats. And just as Bev calling the observation of the mountains behind Blackpool Tower and White Swan because it always looks similar, this observation is no different. Out of the many times I've been there in the past year, it's looked the same every single time. Tommy was even able to add a horizontal plane which extends from my observation point to mimic what I saw when I took my auto level out there. And of course, it matches pretty much exactly what I see in my observation. Some people on the other side will tell me that I'm using my auto level incorrectly, and that I'm using it outside its effective range. Well, after hearing this several times from several different individuals, I wanted to find out exactly why my tool was supposedly inaccurate after certain distances. Luckily, Google wasn't shy about showing me exactly why tools of my kind are inaccurate after a distance. In many surveying manuals, they talk about errors, and different types of errors that can arise when taking measurements. The 2 types of errors that are encountered in surveying are systematic and random. In this document, it clearly states that one systematic error would be not applying curvature and refraction constants. In this one, it states for long sights the correction for curvature has to be applied. In this one, it states that the Earth appears to fall away with distance. The Earth appears to fall away with distance. Interesting. This one states when distances are small, errors are negligible. But for greater distances when backsight and foresight are not balanced, a systematic error of considerable magnitude is produced. This one states that geodetic surveys of large areas are affected by and must take into account the curvature of the Earth. This one has an entire section on adjustments for curvature. This one talks about how to eliminate that supposed non-existent curvature. Even George was able to provide me with a manual for his total station, which again has an entire section on correcting for refraction and Earth curvature. So according to all these references, over long distance, if curvature and refraction aren't accounted for, errors will arise. And I'm sure that every single surveyor on the planet would agree with me. Now for those on the other side who claim to have surveyed or used these pieces of equipment in their everyday profession, and I'm speaking specifically to Rakia and Bev Try Thinking, consider this question. Is the entire industry of companies who manufacture equipment for surveying and the people who write the textbooks and reference manuals on how to survey properly somehow incorrect, deceiving, and hiding something from the public? Or maybe your distorted understanding of surveying and the world as a whole is incorrect. I'll let the viewers decide. Anyway, once again, thanks for watching. Don't forget to like, share, and subscribe if you like this video, and check out the rest of my videos if you're interested. And as always, peace.
Pinpoint asteroids in orbit, then hurl y'all thousands of miles an hour towards it.